Hello, I'm Jason with ScienceandMath.com, and in this experiment we're going to start to work with dry ice, and we're going to use it to create dry ice bubbles. So there's a ton of stuff to learn in this experiment, and it's really fun to do and pretty easy to do actually, but we're working with dry ice. Dry ice can be dangerous, so you have to do this with an adult if you're a youngster, and you just have to get permission because dry ice can actually hurt you, and we'll talk a little bit about why that is in a second. But first, let's get to the actual experiment. What you will need for this experiment is some dry ice, which is, just so you know, frozen carbon dioxide. You can get dry ice at most grocery stores, sometimes in the butcher department, sometimes it's in the front of the store. Just ask around, but this is usually sold in the grocery store. You'll need some duct tape. You will need some clear plastic tubing, and you'll see what that's for in a little bit. You'll need some kind of fitting that you can plug into this plastic tubing, and we'll talk a little bit about that later. You'll need a 2-liter bottle, just an empty 2-liter bottle. You will need Dawn dish soap or some kind of dish detergent because we are going to be blowing bubbles. And you'll need some kind of tongs to help us out with this experiment. And you'll also need, obviously, safety glasses because this is kind of a, I don't want to say it's dangerous, but you need to be careful with dry ice. And also you might need some mittens also when we're working with dry ice as well. So as you can see, there's not too many things really to this experiment. There's the dry ice, there's the tubing, there's the 2-liter bottle, and a few extra things like tongs. One thing you do not want to forget is to put your safety glasses on when dealing with dry ice. So let's take and put some of this stuff off to the side because we're going to use some of it here in a little bit. So I'll put the soap over there. I'll put the dry ice front and center for you here so we can see it. And we'll use the duct tape here in a minute as well. Before we actually do the experiment, which is blowing, carbon dioxide bubbles or dry ice bubbles, we want to talk a little bit about what this stuff actually is because it's interesting, it's fun, and also because it's, it can be dangerous. Just like anything can be dangerous, but once you know how to handle it, once you know what it is, you are well protected. So what is this stuff? It looks like ice, and it's called dry ice. But in fact, it's quite different than any kind of ice that you have in the freezer. In your freezer, you have frozen water. That's what we call ice. When you take frozen water, it's at 0 degrees Celsius. If you add heat to it, it melts into liquid. If you add heat to the liquid water, it boils and becomes vapor, gas, right? So 3 states, solid, liquid, gas for regular old water. Now this stuff is carbon dioxide. So that's the gas that you breathe out whenever you exhale, carbon dioxide. If you take carbon dioxide and put it in a super cold freezer, eventually it will cool down and it will become solid, like these guys right here. So these guys are solid chunks of, look like little ice cubes, but they're actually frozen gas. Now if you kind of notice, a little bit, if you kind of look down at it, you might see a little bit of smokiness going on here. It's not really smoke. What happens is this stuff is really, really cold. It's much colder than regular ice. And just to give you an example, regular ice is 0 degrees Celsius, right? This is negative 78 degrees Celsius. So if this is where ice is at 0 Celsius in your regular old freezer, you have to take carbon dioxide 78 degrees lower than that in order for it to freeze. So the reason it's dangerous, so to speak, is not because it's poisonous, it's just because it's so cold. If I get my fingers and start playing with this stuff and start trying to grab it and just play around with it, my fingers will actually freeze because it's colder than an ice cube, much, much colder. So I can get frostbite. I can freeze my fingertips and cause all kinds of blistering and things like that. So you never, ever, ever, ever want to touch this stuff with your hands. You have to use mittens or you have to use some kind of a tongs, which is what I'm going to do today. And you always want to wear safety goggles or some kind of protection to help you out with this. So what it is frozen carbon dioxide gas. So this is very, very cold. Now the other thing that makes it different than regular ice is that this stuff doesn't exist as a liquid carbon dioxide. See, with water, it's ice cube, liquid water, gas, which is water vapor, right? And you can go solid, liquid, gas. With this stuff, it doesn't exist as a liquid at the pressure that we live at here on Earth. So when you melt dry ice, it doesn't go to liquid, it goes straight from solid to gas, straight from solid ice cube or solid frozen carbon dioxide cube, dry ice cube, to gas carbon dioxide. And so it doesn't go through liquid. And that has a special word in science. It's called sublimation. So it's a little different than a regular ice cube. It's just the way it behaves. It goes straight to gas. Now let me kind of cut to the chase just a little bit and show you what actually happens before we blow our bubbles. I want to show you a little bit what happens when you actually put this stuff in water. So here's some warm water. Not going to put too much, just going to fill it up a little bit. And what we're going to do is just take one of these regular size cubes here and drop it in the water and see what happens. Let me actually switch this guy around here, put this guy right over here, and we'll put this guy right here. So let's grab one of the medium-sized cubes, drop it in there. And you can see that what happens immediately whenever you put it into water is it starts making this fog-looking stuff. It starts making this Halloween-looking stuff. So what's happening here is we're putting this very cold dry ice directly into a warm liquid, because I have warm water here. And so what's happening is the solid carbon dioxide is going straight from solid straight to gas. It's melting, basically. Just like if you take an ice cube and you put it in water, it melts. But ice goes from solid through liquid, and then if you heat it up some more, it goes to gas. Dry ice doesn't go to liquid. It goes straight from solid to gas. So that's why we see all the gas here. Now, if you kind of swirl your fingers around the gas, it feels a little bit cool. That's because the stuff is really cold. The dry ice is actually very cold in there. And what you're seeing here is carbon dioxide. Now, I want to make sure you understand, the fog you see, the white, puffy, smoke-looking stuff, that's not the carbon dioxide. Carbon dioxide's invisible. I mean, think about it. You breathe it, right? So when you blow out, and you breathe in, you blow out again, you don't see the carbon dioxide. That's invisible. But the carbon dioxide, when it comes off of the dry ice cube, is so cold that that cold carbon dioxide gas is condensing the water in the air. And that's the cloud you see. So the visible stuff, the cloud-looking stuff, that's water vapor that's condensing, that's in the air. The carbon dioxide itself is very much odorless and invisible, and you can't see that. So you're seeing a mixture of the two here. Now what's going to happen is if we leave this here long enough, you can see the cube still down there in the bottom, bubbling away, it's going to eventually disappear. It's going to go from a cube, it's going to disappear because all of that carbon dioxide is going to leave. Now it makes for some really fun effects because you can make these nice fog effects, and what we're going to do is use this to basically try to make some dry ice bubbles, to fill some bubbles up with this guy. That's the point of this sort of experiment here. So let me go ahead and move this over here and move my dry ice back where we started. And what I have here is a tube. This is a flexible plastic tube. It's clear. You can buy this at the hardware store. It costs a couple dollars. And I have a fitting here. It doesn't really matter what kind of fitting. I just wanted something I could wedge into the bottom of this and to give me a little bit of a wider opening. So I'm going to stick this in here. I'm just going to wedge it in there. The only I'm going to blow my bubbles out of the end of this, so I just want to have it a little bit larger. So imagine you kind of blowing on this end here, then bubbles are going to sort of pop out the other end. So the next thing we need to do is make our bubble solution and figure out how we're going to channel this smoky carbon dioxide water vapor mixture into our bubbles to make these really cool bubbles. All right, so the next thing we want to do is go ahead and make our soapy mixture. This is what we're going to blow bubbles with. So we'll take our dish soap and we'll just put sort of a healthy amount down on the bottom. And then what we'll do is we'll take some of our water and we'll just sort of make, just like you would blow bubbles, you know, with a bubble wand, we'll make like a little solution of that and see if we can get that to make bubbles. So what we'll do is we'll just use our little finger here to stir this up. There's nothing dangerous here. It's just water mixed with dish soap. Now you may have to play with the mixture here. You might have to play with the amount of soap that you have in order to blow some good bubbles. Now to go ahead and test it, all you do is stick it in the end there, kind of wiggle it around and blow a bubble. And we can see that we're making bubbles, so we're doing good. So we'll go ahead and put this off to the side. And the next thing we're going to do is create a way to channel this dry ice carbon dioxide into our bubbles, right? So that's what we need to do next. So what we're going to do is we're going to drop our dry ice in here. And so we need some water. So let's go ahead and put this water in here. Now this is warm water. It's not super hot. You don't want it to be super hot. You want it to be nice and warm. And you want to fill it up about halfway or maybe a little bit more. So this is about where we want it. We want water that's nice warm water, not too hot, not too cold, in about 3/4, 2/3 of the way up this bottle. Now what we need to do is figure out a way to connect our bubble blower with this. And I have a saying that in the house that duct tape can be used for just about anything, and that's what we're going to do here as well. So let's just sort of grab a nice bit of duct tape. It doesn't really have to be, you know, too tight. It just needs to be tight enough to secure this hose into the top here. So this guy's going to go in here and we're going to tape it in place. But before we actually do that, we want to get the dry ice in there and ready. So we're going to have that set aside. We're going to put the dry ice right over here. And now we're almost ready to go. We have our dry ice, we have our bottle, we have our bubble solution here. And what we're going to do last is put a little rag out. You don't want to get a nice towel, you just want to get a nice little rag that's sort of beat up and something you don't care about. Basically, when you blow these bubbles, the bubbles are going to want to stick a lot better and not pop if we kind of let them land on this little towel. So that's why we put that there. All right, so we're about ready to go. What we're going to do is we're going to drop some dry ice in here until we start to see a nice cloud form. Then we're going to stick our tube in there and duct tape it, and then we're going to start to submerge into the bubble solution and go from there. So I have a lot of dry ice here. Some are too big to fit, but I have these nice little pieces. You can kind of break it up with a hammer and drop one in there. So we'll just kind of go one at a time. You can see some are easy to fit and some aren't. So I'm just going to drop a few in there until we have enough where I think we can actually start blowing some bubbles. Okay, so we have 3 or 4 bubbles of dry ice, blocks of dry ice in there. You can see that they're rapidly releasing carbon dioxide, which is coming out. It's hitting the water vapor in the top of this guy and condensing it. That's the cloud you see. And now we're ready to actually start to try to do this, guys. So let's take our tube. We'll just put our tube in there, and we'll just take some duct tape and just make a nice little seal to force the majority of this gas to go out here. And I'm going to put one more piece just so we don't lose anything right off over the top, just like that. Again, it doesn't have to be really tight because you're not really putting a lot of high pressure through here, you're just trying to channel it. So what we're going to do next, and you can see we have our little gas coming out there, we're going to put it in there and start to blow some bubbles. And there is a dry ice bubble. We'll bounce it off, and it popped there. Let's see how big they can get. Let's just kind of hold it there and just see when it's ready to let go. And I'm going to try to let it drop down into the little soap that's dripping down above here and see if it'll detach. Almost. But you can see these bubbles are full of this this carbon dioxide gas with water vapor. There we go. So we want to tilt it to the side a little bit, and we can get them to detach and kind of land on our towel a little bit. All right, and whenever you're done looking at them, you can just touch them, poof, and there it goes. See if we can get one to stay. Sometimes they say, sometimes they don't. So basically that's what's going on here. We're taking the dry ice, we're causing it to sublimate inside, and we're channeling the carbon dioxide plus the water vapor through a tube and into some bubbles. When you're done looking at them, you can just pop them. 1, 2, 3. So it's a lot of fun. Just make sure whenever you do this that you don't cap off your bottle, that you have to have a place for the air and the carbon dioxide and the water vapor to get out so you don't build up dangerous pressure inside of this bottle. And now we're going to have a grand finale for these blowing of these carbon dioxide bubbles, or these dry ice bubbles. So before we had sort of the little bubble wand blowing small bubbles. Now we have a large bowl with warm water inside and a lot more dry ice. And what we're going to do is try to blow a bubble with the entire bowl. So here are some large pieces of dry ice. Notice what happens when I put them in. Lots and lots of action. So we'll put that in there. We'll put some more. Immediately starts to bubble. Put some big chunks in there. Something like that. All right, now I have a piece of a rag that I've cut here, and what we're going to do is sort of put that into our bubble solution. And what we want to do first is we want to kind of get some nice bubble solution right along the edge, along the lip. We want to hold our rag out kind of flat. This is a little bit messy here. I promise it's worth it. And we'll just go around the edges, dragging this bubble across. Now you can see we formed a bubble right across the top of the bowl, and it's getting larger and larger, the pressure increasing inside from the gas that's coming up. Eventually it'll pop and should spill right over the top. So let's check that out. You can actually get these things pretty big too, if you dare, so to speak. So here we go. It's already kind of outgrown it completely. It's so tempting to actually just pop it right now, but I'm kind of curious how big it's going to get. Now this is not going to make a mess as far as the bubble part of it goes, because what it's filled with is gas. So as soon as it pops, it's going to spill over. The water and everything is still in the bottom there. So here we have almost like a little brain. You know, let's see how big we can go. And there it goes. And it just spills right off of the top. Now that was actually cool enough where we're going to do that again. So we just go from here, drag it across, create the film. Now one tip I can give you when you're doing this, because it took me a few times to actually get this to work, do not fill the water level all the way up in this bowl, because it's bubbling so much inside it pops the bubble. You want it about halfway or maybe less, and then the bubbling that you hear is not impacting, you know, it's not hitting the actual bubble on the top. So there you go. And again, it's so tempting just to go ahead and pop that guy, but we're going to let it go one more time. I wish there was a way I could just blow it and have it float off, but obviously one thing that, you know, I didn't point out that's very important for you to understand is when we were blowing the small bubbles, notice how the small bubbles were sinking. The small bubbles didn't float away, they sink. And that is because carbon dioxide is heavier than air. It's more dense than air. Now, there's a couple things we want to talk about to understand the science here. We talked about dry ice. It's frozen carbon dioxide gas. Really cold, really dangerous if you touch it with your hands, so you never ever want to do that. When you put it in water, it starts to release carbon dioxide gas, which is really cold. That cold carbon dioxide gas starts condensing the water vapor, and that's the cloud that you see. You know, you can wash it away, flip it away with your hands and sort of see the vigorous bubbling here. But the cloud you see is actually the water vapor. The carbon dioxide is invisible. Now, if you remember, when we were blowing our carbon dioxide bubbles, there's a science lesson in here because you're filling it with that carbon dioxide gas along with water vapor. Now, carbon dioxide is heavier than air. It's more dense than air. So carbon dioxide is going to tend to sink instead of float. So a regular bubble, when you blow a bubble, it floats away, right? Well, with a carbon dioxide bubble or a dry ice bubble, it's actually heavier than air. And that's why all of those little bubbles, after they kind of detach, they kind of just sat there. They didn't float away because inside that bubble was a gas that was heavier than air. And that's kind of what happens here as well. You notice all of the carbon dioxide is kind of staying inside of this bowl. And if I flick some of it out like this, it kind of runs over the edge and hits the table, and it kind of just hugs the ground as it goes. And that's because it's heavier than air and it wants to go down like that. So the water vapor with the carbon dioxide wants to go ahead and follow that path. So the water vapor with the carbon dioxide gas wants to follow that path. So it's heavier than air. It's extremely cold. You want to make sure and have precautions when you work with it. Always work with an adult or a supervisor whenever you're doing this. You can get dry ice at most grocery stores. It's actually very inexpensive. It's a few dollars for a big block of it. It'll keep in your freezer for a couple days. And when it melts, there's no mess. Whenever dry ice melts, it just goes into the air. So it's not any kind of pollution or anything like that. So go grab it. Go play with it, but do it with an adult and do it with some supervision and do it with some common sense. Don't try to grab this stuff with your hands because it will burn you, it will hurt you. But there's definitely a good science lesson here, learning about gases, learning about density and the fact that the stuff in here is more dense than air, and that's why it's wanting to stay, you know, inside this container, and that's why when we billow it out, it kind of wants to hug the ground. That's an important science lesson there. And the fact that these bubbles can be blown, and whenever we blow those bubbles, they kind of sink to the ground too. So it's mostly a lesson in buoyancy and how the bubbles want to sink, along with learning about dry ice and the fact that it's frozen gas. And it does not go through a liquid phase. When you take dry ice and you heat it up like we're doing with the water, it doesn't go to liquid, it goes from solid directly to gas. That's called sublimation. I'm Jason with ScienceandMath.com. I hope you've enjoyed this experiment. Go get the materials, go have fun with it, use some common sense, and learn about dry ice and blowing dry ice bubbles.